Mathematical modeling is a description of a system using mathematical language. Optimization is the procedure that makes a system as efficient as possible. This is a very useful application of max and min problems. So you did max min problems in grade 11. We're not going to do it the grade 11 way. We're going to do it the calculus way, which actually is way faster than the grade 11 way. Because remember how you did in grade 11? You'd have to get an equation of a quadratic. You'd have to complete the square to get the max or the min value, and then that was your answer. Yes? So we're going to kind of do the same thing, except we're going to use calculus to get the max min. So we're going to use the derivative, find that critical value, set it equal to 0, and solve, right? Okay, so strategy for solving max min problems. Understand the problem. You might need to read it several times. Develop a mathematical model, meaning draw a diagram, write down equations, variables, etc. You need to identify the critical points and investigate the endpoints if applicable. You need to test the critical points and endpoints to find the solution and then interpret the solution. Okay, let's start the first problem. You have 40 meters of fence to enclose a rectangular garden alongside a barn. What is the maximum area that you can enclose? So you know this is an optimization problem because it says maximum in there, right? So we're going to come up with a come up with a formula. So the first thing is we need to understand the problem. So does everybody see we're trying to find a maximum? Yes? We have 40 meters of fencing. So we are going to enclose this with a barn. So that means we have lengths and widths and lengths there. So a length, a width, and a length. Or we could have two widths and a length. However you want to do it. We can do x's and y's if you'd like as well. What would you like to use? X's and y's. So if this is x, this would be x. Everybody agree? And this would be y. What would my formula for what we're trying to find, meaning area? Area would be equal to what times what? It would be 2x times y? No. It would be x times y. Length times width.
I thought we were taking away No.
The area is different than perimeter.
Oh, yeah.
Okay, so the other bit of information that we haven't actually done anything with is right now we have 3 variables here. And so we want to get it so we have 2 variables so we can do implicit differentiation. So the other bit of information is 40 meters of fencing. So can anybody come up with a formula that would use the 40 meters of fencing?
2x plus y equals 40.
Yeah, 2x plus y equals 40. Does everybody see? That would be my perimeter. Yeah. So what I'm going to do is I'm going to solve for one of the variables. It doesn't matter which one you do, because in a second we're going to maximize the area. And if I maximize the area the way it's written, we're going to have 2 variables here, and we'll have to have all these craziness going on. So I'm going to solve for y because it seems like it's a pretty easy thing to do. Y would equal minus 2x plus 40. And then I'm going to sub this into the y over here. So I get a new area formula, which is x times minus 2x plus 40. Except I would never try to find the derivative the way it's written. Does everybody understand? You should try to simplify this before you do anything. So a equals minus 2x squared plus 40x. Yes? Okay, so now I'm going to maximize the area, and the way I do that is by finding the derivative. So a prime would equal minus 4x plus 40. Does everybody see what I did? Now I'm going to find the critical value. So how do I do that? I set it to 0 and solve. So 0 equals minus 4x plus 40. So x would equal, move it over, divide by 4, what do I get? 10. So just to be on the safe side, to make sure we did a maximum, I would do a sign diagram of A prime, right? and I would put 10 there. And it's up to you where you want to do this. Probably around here, I would just factor out a -4, and I'm left with x minus 10. That's easier to do a sign diagram, right? So if I say take something on the left, mind you, this would be at 0, right? Does anybody know the minimum would be, that the minimum would be 0? Because you can't have a negative area. Okay, so if I pick up a number on the left of 10, say 9, do you see I get a negative times a negative, which is a positive? If I take something on the right, say 11, I would get a negative. Does everybody see this would indicate a maximum? Yeah. Okay, so let's answer the question now. What is the maximum area? Oh, so I have to actually answer what's the maximum area. I know that x is 10. What's y going to be?
20.
Plug her in. Do you see that y would be 20? So then my area would be 10 times 20, which is 200, what is that, meters? Meters squared. The question asks you for maximum area. So although I found the width, say, when is the maximum area, they're asking for the maximum area.
What's
So
the point of doing that sign?
the point of the sign diagram is to make sure that, in fact, I did find the maximum. Do you know what I mean? If this was a multiple choice, I would never know if you did that or not. However, you might want to do it if you had time, just to make sure that you ended up finding the maximum.
If it wasn't the max,
A rectangular box with a square base and no top is to have a volume of 32 meters cubed. Find the dimensions for the box that require the least amount of material. Does everybody understand the least amount of material is surface area, right? And I know it's been a while since you dealt with surface area, but I don't know. Surface area is basically all the areas added up, right? So it's not like it's hard. Okay, so let's label this box. We don't know the length, we don't know the width, we don't know the height. So
The length and width are the same.
the length and the width are the same. So I'm going to label this X and X. Does everybody see? Because it's a square base. I'm going to label the height as Y.
yeah, see,
Well, then you might have 3. There, with a square base, no top. Can anybody come up with the formula for volume of this box?
L squared.
X times Y, so that would be X squared Y, yes? And they gave you that the volume was 32, so 32 equals X squared Y. So now I've used the given information, however, that we're not talking about minimizing the volume, they're talking about minimizing the surface area. So I need to come up with a formula for surface area. I'm going to call it A for surface area. Instead of SA, you could call it S. It doesn't really matter. Can anybody come up with a formula of this box for surface area?
X squared plus 4y.
X squared, because there's one square at the bottom, plus what?
4x.
Plus 4xy. Does everybody see? That would be the surface area of the box. It's an it's an open top, so there's no area on the top. There's a square bottom, and then the 4 sides going around, that's all an area of xy. Yeah. So if I were to find the derivative right now, does everybody see I have 3 variables? I need to get it down to 2. So this right here is going to help us. If I solve for y, I will be able to replace this y. So does everybody see y equals 32 over x squared? Yes? Now I'm going to replace this into there. So I'm going to come up with a new formula. A equals x squared plus 4x times 32 over x squared. Of course, we need to simplify everything before we find the derivative. And I would probably write the x as an exponent with a negative power versus leaving it on the bottom. So does everybody see this as x squared plus what 2?
4x is 32 over x squared.
Yeah, it would be.
Yeah. So 32 would be 128 x to the power negative 1.
Yeah.
Is everybody good? I'd rather have it as x to the power negative 1 than over x because it's easier to find the derivative. So a prime, again, remember I'm trying to minimize this, right? So to minimize this, I'm finding the critical value at the derivative. So that means I get 2x minus 128 x to the power negative 2. So we're going to set that equal to 0. So we can find our critical point. 0 equals 2x minus 128 x to the power negative 2. So we need to solve, right? So, well, now what? This is just algebra skills now, right? I'd probably move this over to the other side. So I get 128 x to the power negative 2 equals 2x. Do not, whatever you do, divide by an x. I could divide by 2, and I get x equals 64 x to the power negative 2. Say that again? Yeah, like you want to bring this over to the other side. So if I multiply both sides by x squared, yes, I get x to the power 3 equals 64. And then I cube root it, I get x equals 4. Now normally I would get plus or minus, but it's a cube, right? Say what? But you can't what? It can't be negative, but it's a cube root. So, and I know it you know what I mean. So yeah. So just to be on the safe side, does everybody see again? Your x can only be as low as 0. Just to prove that it's a minimum, if I put 3 in there, now you might not be able to see this very clearly. So what I'm going to do is I'm going to rewrite this with a 0 equals, or a prime I should say, a prime equals 2, and if I take an x out, I'm left with 1 minus 64. If I take an x out of that, does everybody see I'll have an x to the power 3? No, if I'm going to do my sign diagram here, just, again, this is probably on a multiple choice, so you probably wouldn't even have to do this necessarily, only if you had time. But I want to make sure to show you that this is a minimum. I want to show you to make sure that we have a minimum. Yes? Yes, it would be. Thank you. So a prime equals 2x. And so then, does everybody see this is the same thing as x cubed minus 64 over x cubed? So now you can see it a little bit better. If I put a 3 in there, do you see you'll get positive here? What do I get here? Negative, and that'll be positive. So do you see I get a minus? And if I put a 5 in there, 5 cubed will give me a plus. So does everybody see this is a minimum? I should be recording this. The A prime sign diagram is re-solidifying the fact that I found the minimum because it's going from a minus to a plus. Yes? Again, if it was multiple choice and you didn't have much time, I would just get the answer and go. Now, it does say find the dimensions. So, no, it says the least amount. That's not maximum, right? So, therefore, what's my answer? The box is 4 meters by 4 meters by, yeah, and if you didn't know, you plug it in, right, for y here, and this is 32 divided by 16 by 2 meters. So it's not too bad, like it's kind of like using your grade 11 stuff to the next level, right? So, okay. There's 40 hot dog vendors at a football game, and their average profit is $108 each. This average profit decreases by $2 for each vendor added. How many vendors should be added to maximize the overall profit. You did this in grade 11. So, by the way, these questions are huge. If you were to take the calculus for management students, they will throw lots of these ones where you're trying to maximize profit and things like that. They like those kind of, because the world runs on money. Sorry. So instead of having abstract, like this would be in the general calculus. A question like this would be in the calculus for management students. So, anyways. So, I know how I taught this in grade 11, but I don't know how you did this. You don't remember? I know I always said if you have no idea, do a little chart so you can see what's happening. For instance, you know, so for instance, if you have 40 hot dog vendors and their average profit is $108 each, so yeah, if you have the number of vendors, right, and this is their average profit is $108, right? This is overall profit. That would be this times this, right? Whatever 40 times 108 is, right? The overall profit of all the vendors. It's saying if you decrease $2 for each vendor added, meaning this is going up by 1, this is going down by 2. Do you see what's happening? I will repeat. It says for every decrease by $2, the vendor for each vendor adding. So if I add a vendor, it goes up by 1. That means this goes down by 2. This is number of vendors. This is average profit. This is overall profit. So again, what do I get? It'd be 41 times 106. When we did this in grade 11, we now came up with a formula. So what's happening each time? This is going up by 1x. I'm going to put a 1 there just because it's what happens here for every vendor I add. This is going down by 2x. Yes? And my overall profit is equal to this times this. Yes? Again, it should look fairly familiar because you did do this. A lot of the questions were like admission to a theater, blah, 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 you know. So anyways, so we are going to calculate this. So this is, we'll probably grab our calculator at this point because these are bigger numbers. Well, if these are big numbers, we're not going to say you need to. So this is 4320. Outer is minus 80x. Inner is plus 108x. And then last is 2x squared. It's a FOIL, you guys, right? So P equals minus 2x squared. That would be what, 28? So plus 28x plus 4320. So now we're going to maximize the profit. How do we maximize? We find the derivative. So P prime is, what do we get there? Minus 4x plus 28. It's pretty easy. Like this is way faster than completing the square with this crazy number, right? So 0 equals minus 4x plus 28. 28. So x equals 7. What does 7 stand for? That was the amount of added vendors. So now, how many vendors should be added? So we should add 7 vendors. Well, look.
47 vendors in total.
Right, 47 vendors in total. It's saying how many vendors should be added. So I should be adding 7 vendors. And what's the maximum profit?
47 times 418.
So that would be P, the maximum profit would be 47 times 108 minus 14, right? So that's 94. So 94 times 47 is $4,418.
So I know. Wait, 108
Wait, so you don't have to do a,
So let's just do a quick, this one's a quick one because it's not like it's P prime, here's 0, here's 7. If I factor it right here, does everybody see if this factored, if I pull out a minus 4, I'm left with x minus 7?
dollars.
So if it's 6, I'll have a negative times a negative, which gives me a positive negative. So does everybody see it's a maximum? Yeah. So, alrighty. Now we got poopsie plans to develop a new 1 liter pop that will use the least amount of packaging. What's the dimensions of the can that will use the least amount of material? Okay, I'm going to give you a chance to just start working on this. Okay, so volume of a cylinder is equal to, and the way you should remember this is volume is always the base area times the height, and the base area is pi r squared and times the height, yes? The surface area, if you remember what surface area was from grade 10 or grade 9, it is 2 circles with a rectangle wrapped around the 2 circles, right? And the rectangle that's wrapped around is the circumference times the height, right? Like you have this circle on top, and you have this rectangle like this with a circle. So this is 2 pi r, the circumference. This is the height, right?
Yeah.
So it's going to be 2 pi r squared. Why is it 2 pi r squared? Because it's a pi r squared and a pi r squared. A top and a bottom makes 2 of them, right? And then you have to have the rectangle, which is 2 pi r times the height. So again, we can't have 2 variables to maximize, right? Okay, so it does say a 1 liter pop can and 1 liter is 1,000. So we're going to use 1,000 obviously because the radius and stuff is going to get down to centimeters. So that means 1,000 equals pi r squared h. So now when I put this into my second formula, I'm going to substitute it for h because that's the only one that has the extra variable. So what would h equal? 1,000 divided by pi r squared. Does everybody see that? So area is going to be 2 pi r squared plus 2 pi r times 1,000 over pi r squared. So I'm going to simplify that. The pi's will cancel, and one of the r's will cancel. So then this is area equals 2 pi r squared plus 2,000 r to the power negative 1. Is everybody good with what I did there?
yes.
So now I'm going to find the derivative so I can find the minimum, right? So a prime would be, does everybody understand pi is a constant, so it's not a multiplier? No, but when I put this 2 here, it's going to be still 4 pi, right? So 4 pi r to the power 1, and then this will be minus 2,000 r to the power negative 2. Yeah. So 0 equals 4 pi r minus 2,000 r to the power negative 2. 2,000 r to the power negative 2 equals 4 pi r. Yes? So if I multiply by r squared to both sides and divide by 4, I will get 500 r cubed equals pi. Sorry, I did that wrong, didn't I? I'll try that again. 500 equals pi r cubed. So I need to solve for r, so I do need to get rid of the pi, right? So what would r equal? The cube root of 500 over r. Over pi, sorry about that. Over pi. Oh my gosh. Okay, it says what's the dimensions of the cam? So, no, that's the radius. I need to have the height. So the height is 1,000 divided by pi r squared. So stop it. It's easy. It's easy. So this would be the cube root of 500 over pi, and that would be squared, right? So the good news is, in calculus, you can leave it like this. You do not have to simplify. I do need to put, you don't. You don't. However, if it was a calculator answer, it probably won't have this as your choice of the multiple choice, right? So anyways, do you guys want, for fun, punch this in so that you should have, see, this is what happens. You say, oh no, let's just go move on, and then you don't know how to punch it in. Okay, so this is centimeters, right?
No.
Okay, the revenue earned by a business based on the number of items in thousands produced is r of x equals 9x. The cost, c of x, is equal to x to the power 3 minus 6x squared plus 15x. What production level will maximize profits? So profits is equal to,
revenue earned by businesses and items and
see, and this is where the business sense in you needs to come in. How would I figure out profits?
Profits equals r of x minus c of x.
Does everybody understand? This should make sense to you that profits should be revenue, which is r of x minus c of x. In order to make money, the money that you take in has to pay how much it costs you, and whatever you're left over with is what your profit is.
I think the reason why I didn't see that first is the way the question is worded.
Okay, so P equals 9x subtract bracket x cubed minus 6x squared plus 15x. So P equals 9x minus x cubed plus 6x squared minus 15x. So that will simplify to be negative x cubed plus 6x squared plus, yes, minus 6x. Okay, so then again, in order to maximize profits, we need to derivative. P prime is negative 3x squared plus 12x minus 6. So set it to 0. 0 equals negative 3x squared plus 12x minus 6. Try to factor, but I wouldn't try to factor when it has a minus 3 in there. I would just switch all the signs. 0 equals 3x squared minus 12x plus 6. That's like multiplying both sides by negative 1. I wouldn't factor out a negative. I would get rid of it. Does this factor? You can factor out a 3. So let's divide both sides by 3. So 0 equals x squared minus 4x plus 2. And it's very noticeable now. I cannot factor. So then what's my next mode of choice? Quadratic formula. So x equals minus b, so 4 plus or minus b squared, the square root of b squared, so that would be 16, minus 4 times 8 times c, so minus 8, all over 2a, so all over 2. So x equals 4 plus or minus the square root of 8 divided by 2. Now, in order for us to have a true answer, we can't have, which one can't we have here? So, well, hold on. The square root of 8 is approximately what? It's 2 root 2, but do you see it's just a little bit less than root of 9, which is 3, and that means we could have both. So, which means then we need to figure out which one's the maximum. So we need to simplify this, the bigger one. That's not necessarily the case. So this is 2 root 2 divided by 2. So this is 2 plus or minus root 2. Does everybody see that? So on my sign diagram, I'll have 0, and I'll have 2 minus root 2, and I'll have 2 plus root 2. And just for kind of, you know, fun, you can kind of do a rough estimate. What's root 2 approximately? Yeah, about 1.4. So this would be about 0.6 if you're thinking. And this would be about 3.4, just so when you're subbing stuff in. Now, let's go back to... it's about 0.6. About 0.4, 3.4. Yeah. So, you know, take something that's, say, a quarter or something like that to be on the safe side. And if you got to pick one of these, probably over here would be the easiest, right, to see if it's positive or negative. So a quarter squared is little. This minus that is...
Negative.
It's going to be negative. Is it going to be more than the plus 2? So that means it's going to be negative. On the right of this, let's pick something that's easy. 1, yes. 1 minus 4 is negative. 3 plus 2 is negative.
Oh no.
Is it? Is it? Let's take a 3 though, because I think it needs to be a little closer. If I do 9 minus 12, that would be what? That would still be negative, hey? Okay, well then let's do on the right of this. Let's pick something like 10.
100 minus 40.
That's going to be positive.
That's a minimum.
So I think I need to recalculate this then, because I'm thinking it's this over here. So let's pick something and actually calculate, because this has to be a plus, because that's the only way we could have a max, right? 0.5. So 0.5 is 1/4 minus 2 plus 2. So yeah, it is plus. Yeah, there you go. Okay, so that means here is our maximum, right? So it says what production level?
Production level must.
So that means I need to produce 2 minus root 2. Therefore, must produce 2 minus root 2, what is it, items? To max profit. So that's, you know, the one case where that would be the case there.
Please make hatch an item.